Here three complex numbers are given to us, z1, z2 and z3, and we have to prove that z1 into the imaginary part of the product of conjugate of z2 and z3 plus z2 into imaginary part of the product of conjugate of z3 into z1 plus z3 into the imaginary part of the product of conjugate of z1 and z2. This is equal to 0. So we are going to find all these three terms and we add all these three together to get this 0. Let's take z1 to be as x1 plus iota y1 and z to be as x2 plus iota y2 and z3 x3 plus iota y3. Then to find out the product of conjugate of z2 and z3, right? What is the conjugate of z2? That is x2 minus iota y2 into z3, x3 plus iota y3. Simplifying this, we get x2 into x3 plus iota x2 y3 minus iota y2 x3 plus y2 y3, because iota into iota is iota square, that is equal to -1, and that gives us the positive sign over here. This implies the imaginary part of the conjugate of z2 and z3 is equal to, yes, from here x2 y3 minus y2 x3, and then therefore just multiplying z1 with this, we get x1 plus iota y1 into x2 y3 minus y2 x3, that is equal to x1 x2 y3 minus x1 y2 x3 iota y1 x2 y3 minus iota y1 y2 x3. Similarly, we can find these two also. So please match your answer. So it is x2 x3 y1 minus x2 y3 x1 plus iota times y2 x3 y1 minus y2 y3 x1, and this is equal to x3 x1 y2 minus x3 y1 x2 plus iota times y3 x1 y2 y3 y1 x2. So let's mark these as 1 and this to be as 2 and this to be as 3, and adding 1, 2 and 3. We get, here in the first term I'm having x1 x2 y3 and this is cancelled out with this, right? Then is negative x1 y2 x3. Let's find out this, the positive one, x3 x1 y2, right? Then is iota times y1 x2 y3. So y1 x2 y3, this will be the negative term, so this is cancelled out with this, and then is negative iota y1 y2 x3. Negative, we have to find out the positive one, y1 positive y1 y2 x3, and then x2 x3 y1 is cancelled out with this, and y2 y3 x1 with iota negative sign cancelled out with this positive one, y2 y3 x1. Very fine. So by adding all these terms we are getting this to be as 0, right? Thank you.